So this is my first Milwaukee JS meetup, which is embarrassing. I had a baby recently, and that's my most recent excuse. Otherwise, I just have a bunch of other excuses. Anyways, my name is Ivan, and what I'm going to talk about today is writing JavaScript, and specifically using an open source framework, library that we published at work to help you write it in such a way that you don't need to write documentation or take your headphones off to answer questions as much. A quick definition. So when I say self-documenting, I'm not talking about like writing code with like JS hint doc or JS doc hints. You know, like I'm not talking about any sort of actual typing. This code, the aim of this and sort of the thought exercise of this is to be able to not have to write documentation at all, which is a lofty goal. A quick about me. I'm a JavaScript developer at Northwestern Mutual. I have a Twitter handle that I've just been trying to make myself use as I put the baby down for naps. I don't use it that much, but I'd like to, so make me use it. I have a website, Eisenberg.ninja. I will publish these slides there. The only band-related plug I'm going to give, I play in a local string band for anyone that likes bluegrass kind of music called Pay the Devil. I'm a banjo player. A quick obligatory nod to Northwestern Mutual. So this is a picture I took from my desk this winter. It's a pretty beautiful tower and it's a pretty cool place to work, and if you're looking for a cool place to work, I can probably help you talk to somebody that could help you work there too. Okay, an example problem. So let's imagine that we're going to write a JavaScript application, and for the purpose of this demo, so a really quick disclaimer, I gave this talk internally at Northwestern Mutual and just used actual source code and stuff. So this is the bleached version of that. So I think it reads well, but anyways, we'll see. So this application is going to care about the weather, and it's going to give users advice on if they should wear a coat or not. To keep it simple. Our data, is this big enough? I know it's pretty washed out. This is an object literal. There's a temperature object with two properties, temp and temp min, that represent the current temperature and the low temperature and the chance of precipitation. This is based loosely on openweathermap.org, formatted to fit this projector. So consider this if statement. So let's talk about needing a code. This if statement is checking to see if chance of precipitation is greater than or equal to 75, or input temp is less than 60, or input temp min is less than 60. Sort of under the guise like maybe it's warm enough for a coat now, but if you're going to leave the house all day, maybe it will get cold. Really, I was just looking for some nested logic. So this is what I came up with. So it's going to say you need a code if it's cold or if it might rain. If it's cold, if it will become cold, or if it might rain. So this is three logical expressions. We have an input object and there's three properties on it. Sort of what we just saw. The logic is grouped. Pop quiz. Does anybody remember why we would need a code? So like if you're writing this application and some jerk meteorologist walks by and makes you take off your headphones and says like, hey, I just ran the app and it said I needed a code and I don't need a code. Why is it saying that? Does anyone remember those specific numbers? Like, we might, we just talked about them a second ago. I don't know if anyone does. I don't even, to be completely honest. And this always irked me. So I would just be sitting there writing code and someone would walk by and say like, why is this happening? And I don't know the answer, but because I understand code, would be the one that of course needs to go look through the code and figure out like, the min temperature today is less than 60, so it might become too cold and that's why it says need a code. Like, is that wrong? Like, should that be higher or lower, or should we not care about that? So this bothered me. At work, I work on an incredibly complicated application that takes like 10,000 line JSON objects with all sorts of, like every year of insurance policy and every type of like actuarial characteristic you could have that all changes different disclaimers, and depending on which state you live in or how old you are or what you've asked for, you get a multitude of different treatments on all of the stuff that we build. So something that always irked me now, like was grinding me to a halt. So the bottom of that question is, what do we consider code weather? The notes here I more or less talked. So like, the only thing I didn't talk about yet is most importantly, so like the jerk meteorologist who wants to know why it's coat weather is a problem. But what if you had a new dev on the team and you needed to explain to them what coat weather is? Like now you find yourself looking through the code and trying to teach them how to solve these problems. There's no easy way for them to answer questions, and they rely on you to help in oftentimes. This, to me, feels suspiciously like madness. I sort of touched on my distaste for this. But this is a silly example because that code, although I think it was written kind of nicely, is stupid. Like, I don't think any of us would litter something like this through our code. What we would do is abstract it, right? So, abstraction with a rescue. So this gets a little bit better. This, I feel like, because of a little bit of ES6 magic, is pretty nice to look at. We create a function. Do I need a code? It destructures that object, so we don't need to care that it's input dot. We get chance of temp and temp min. And then we have that same logic. Chance of precipitation is greater than or equal to 75. Input temp less than 60, temp min less than 60. And then we could use it, like in that bottom statement, if do I need a code, and pass it some data, and it would say you need one. This could probably even get better if these slides were bigger. We could break out each of those pieces of logic into its own pure function and compose them together, probably, so then you could unit test each of those pieces, and like now we're talking about good code. But it still doesn't solve the problem of, I don't remember that the min temperature is 60 degrees 3 days from now. So, even better, this is sort of what I was just talking about. I forgot I added this slide. This is super testable. So here we've broken it out. We have those three functions. We can compose them together. We have unit tests for everything. The unit test sort of serves documentation, and that's great. So we just sort of talked about, but why is this better? There's two reasons, and in no particular order. They are, the logic all exists in one place. So now when the meteorologist asks, you know that somewhere you have a modules folder or something with the do I need a code function, and you can go to that, and that's where it exists. And if you're using like do I need a code in 7 different places that all uses the same 60 degrees, and there's no chance of one saying 62 and one saying 60. So that's great. There's a single source of truth, and because unit testing is important and it becomes trivial to unit test that code, you no longer need to mock up an input object. You can just pass a single property in and get a single response out. So why does this talk continue? What's wrong with this? This should be fine, right? There's nothing wrong with this code, it's fine. But because it's abstracted, it requires some domain knowledge. Like, you have to know that there's a modules folder. I feel like if we asked everyone here, like, I would do it that way. I like to create a folder of modules that sits next to node modules, and they're my internal node modules. They're all just pure functions. And you reference it from there. So I could explain that to you if you joined my team, and you would know that there's probably a function in this folder that you could go look for. But who knows, some other people might want to throw it in common, or some people might want to actually make it a node module and then can install it. The point is that there's not a right way, I think. If there is, someone tell me. And because of that, our weather expert's going to still have a tough time finding this. So our meteorologist isn't going to go find it. He's still going to make me take my headphones off. And that, the more I think about it, is what I'm trying to solve. How can we do better? So this is what we asked. We were just getting bombarded with bugs that weren't bugs and bugs that were bugs, and we couldn't quite figure out what was going on. And stuff was just scattered all over the place, and we had a common folder, and I think we also had a public folder. And it was just getting messy, and there was just inline if statements and switch statements, and it was becoming hard. We ended up creating, based sort of on like a database query, we created this concept of regent that Northwestern Mutual graciously allowed us to work on during work time to abstract out and open source. So you can npm install regent right now if this presentation goes well. So introducing regent. Regent is a rules engine, and we built it to separate the how from the why. So all we're talking about how something works is what I care about. Like, I want to tell the user that it's cold weather, if it's cold weather. And I don't care what cold weather is, really, right? It's sort of similar to the concept of a constant. Like, you can create a constant and you can put whatever piece of text in that, and if the text changes or you need to go uppercase with it or whatever, you don't really care because you're using your constant. And the stake owners of the project, or the stakeholders of the project, can do what they want. So that's the how. The why is the meteorologist specific part. Like, I'm not a meteorologist, I'm definitely not an actuary, and I never will be because my attitude towards academics is poor. So I'm just not going to learn that stuff, and I would like to not have to care about it at all. Like, I want to be told that this insurance policy is of type A, and I don't care why. I will never know why. Regent was born out of necessity. I couldn't have continued. We needed it. So the fundamental part of Regent are rules. So we're going to jump into the anatomy of a Regent rule. There's really not a ton here. It's just an object literal. Each object literal has 3 parts. We'll talk about them in a second. A left function and a right. Oh no, I did not take this one slide. So you can see here we use an @ symbol in that left property to denote temperature.temp. You can remember that was nested in our earlier object. It was temperature, and then that was an object literal too, and there was a temp and a temp min. So we actually just use lodash.get, if anyone's familiar with lodash.get, so it'll parse anything lodash.get will parse. If you don't have an @ symbol, it will take the value as literal, and if you need an @ symbol, double @ symbol will escape it. These are sort of low level details, but if you have like a Twitter handle, @ will only print one @. If anyone can think of a better way to do that, that's something that we argued about a whole lot before we just sort of punted. So this is cold enough for coat. We sort of look at what this is. We're looking at temperature temp. The function is less than. We'll get to that in a second. Right is a literal 60. So this is just going to run a built-in predicate less than. We're not going to get super into it, but it ships. Regent ships with greater than and less than, and Lodash includes and other things, I'm sure, right now. And it also supports custom predicates that we can talk about. So you can do anything that you want. A predicate is just a function that takes 1 or 2 parameters and returns a bool. This is old. This is not key anymore. In Regent 1.0, it was key. It's now left. Anyways, it tells Regent where to find a particular piece of data. The FN refers to the predicate you want to use. Params is now right. We realized that it was better to just have left and right, because then you can use the verb in the function to actually make it human readable. I'm so sorry that I didn't update that. So here's our may become cold enough for a coat. So remember that these were nested in our earlier look. We broke them out into 2 rules. I'm probably going to accidentally say it. So we call these atoms just internally, because atoms are the smallest unit of something. And I actually have a note that I'm supposed to shake my fist at quarks right now. Physics joke. So this is just another atom. So we have the is cold enough for a coat atom, and we have the may become cold enough for a coat. So this documents that logic too. Temperature.temp min less than 60. Probably will rain. This is going to be our 3rd piece of our example. So our left is chance of precip. Remember, this wasn't nested, so it's not in that temperature object. Function is greater than, right is 75. So greater than 75% chance of it's going to rain. I've made all these thresholds up. Even as I say it now, like I would probably want to bring a coat if there was less than that chance. Like that seems pretty high. But that I actually like, because it sort of illustrates the beauty of it doesn't matter what these thresholds are. Like, what matters is that you have a rule that you've named something that hopefully you can read, that it will probably rain. And if someone says, like, well, if it's any % chance of rain, I want a coat, like, that's what our application should do. They can just make that choice, and you don't have to care. So let's try to replace that piece of logic we started with. We're going to compose 2 rules. So Regent ships with and, or, and not, which conveniently are sort of the building blocks of computer science. And it turns out, much like you can build an entire processor out of those things, I guess you need a XOR too. We don't have a XOR. We have our coat temperature equals a regent.or, so cold enough for coat, or may become cold enough for coat. So we've now abstracted those 2 rules out, and we can just create a coat temperature rule. And we don't even, from this point on, we can use this in our application. We don't need to care that it's made up of cold enough for coat or will become cold enough for coat. We've abstracted a level up. Regent or isn't that magical. It's just creating a new object literal with a slightly different syntax. We actually write these out like this. We don't use the helpers on our project. So coat temperature is just, you get a composed key, and you give it an or, an and, or a not, and then you give it an array of rules. So you can just write this, or you can use regent.org to write this for you, whatever you like best. Let's compose this rule with our precipitation rule. So we get a coat weather rule, which is another or. So regent.or, coat temperature, or probably will rain. So now we have this one rule that does what that if statement does. We don't need to know about any of the metrics. We can name these whatever we want. It's just a JavaScript variable that you can import or ship. You can publish it to an API and pull these down. Like everything about this is JSON stringifiable. So if you remember the fn, that's not taking a function, it's taking a string. And then we have a factory function that will look up the fn you need by string. So it's technically, when we started doing this, we have a .NET backend on our project, and we wanted to share the logic, the rules logic across both components. So you could implement regent, and it's only 9K big, and I'm not that good of a programmer, and I wrote it pretty quick. I'm sure you could implement what regent does in .NET really quickly, or in Java, or in Python. The concept of being able to share this logic across applications was big. We had a hackathon where we wanted to, this initially was called JaRule, which I thought was the greatest name for a JavaScript rules engine of all time. And part of doing it on company time was talking to the company lawyers. And the company lawyer sort of looked me straight in the eye and said, you can call it that, but I wouldn't. And then I didn't want to be the person that's like, oh yeah, NM dev culture, where you can name something against a lawyer's wishes and then become like the face of a huge problem. I like that view, and I didn't want to give it up over this. So we renamed it regent, which I had never Googled that word, and I found out that it means like a temporary king who steps in when like the actual king is incapacitated or GM to rule, which ended up being perfect. When I told my wife that it was perfect, she says that I should watch more Downton Abbey with her, and I would have already known that. All right, so we have our coat weather rule. Let's look at in our application. So like this is the why, right? This is the stuff that I kept saying I don't care about, and I really don't. Let's look about the how. So like how do we actually put this into JavaScript to make it do stuff? And it's here. So we've remocked up this data object just so we can kind of remember what it looks like. But the second block is sort of where we're focusing. We're just going to call regent.evaluate, pass in coat weather, pass in data, and it will, if that returns true, it'll log out that you should probably wear a coat. That's it. My next slide is WTF! That doesn't look that much better. Like we've just written all of this horrible code, and we're learning an entire system, and I had to npm install something, and in the end I have an if statement, and instead of calling a function from a module, I'm calling like some regent thing that I've never seen before, and like, what are you doing to me? This is stupid. And I completely agree. You're not entirely wrong. But the good news is that the extra code ends up as rule definitions, and it's intended to serve as documentation, and it will get better too. Burying the lead here. So regent exists, again, to help developers understand the complex rules. So as you go out and write these rules, as you say, much like if you were writing an internationalized application and you needed to tokenize every single piece of text, and you spent the time to think about like, well, I can't tokenize every word because different phrases translate differently in different languages. Like I need to start tokenizing sentences or paragraphs or phrases, or you fight that fight of tokenizing every single piece of text or trying to reuse tokens in different places, running the risk of your translation sort of not making sense in a certain language. That's sort of how I think about regent now, where every time I go to write an if statement or a switch statement or anything like that, a piece of logic, I say like, well, I should just make this a regent rule. We should put it in one rules.js file, and then I can import those wherever I need them. And then anyone that's saying like, why is this happening, can just go look at these JSON object literals and see exactly why something's happening. So here's another helper tool that we've written that hopefully will help see the beauty of it. The syntax will get better too. Regent.explain. So regent ships with explain. Because it's so formulaic and stringifiable, explain will just tear through and sort of do, I don't know, I've talked to some of you about the CLI tool we're currently building, which I'll get to at the end. Regent.explain will output some nice looking text to say why it returned this. So you just call regent.explain, pass in coat weather. That data, the second property is optional, but if you pass it the data that you passed it, it will give you these sort of arrow functions to the actual value that it compared against. So here we have, in these nested order of operation parentheses, we have one big statement, and inside it we have a nested statement here, temperature temp, which in this data object that we passed in is 82.32, is less than 60. Like, obviously that's not true. Or temperature.tempmin of 55.6 is less than 60. That is true, so this is going to return true. Or chance of precip, which is 20, is greater than 75, which is not true. But one of these is true. We can run it through this regent.explain, and the regent.explain will print this right out in your console or to a log file or wherever you have it print. And then you can see exactly why this rule returned true or not. This is also really nice if you're a developer and you see someone using a rule like is coat weather and you have no idea what that is, and instead of asking, you can just pop open a debug tool and run it through regent.explain, and it'll just print out its logic. You can also, if you're using like a VS Code command, click a couple things and you'll jump to your rule definitions and you can read it, but this just spits it right out. The data, I work with a guy named Jesse, and he had the idea to be able to pass in the data, and it's like the most brilliant thing. At first I was like, I don't know if we need that, and now I can't imagine without it. So we are going to talk about a different pattern, and this is how we implement regent most in our project. I think this gets a lot better. You won't get the WTF slide. Logic tables. So the other pattern, and there's a few more helper functions that regent provides, and it's logic tables. So a logic table is nothing more than an array, and the array is an array of object literals. The only convention, the object literals can be anything that you want. The only convention is that each one has a rule key on it at some place, and then the value of that rule key is just a regent rule. So a single regent rule, let's check out this example. So this regent logic table has a value property on each thing, so you should probably wear coat or no coat needed today, and a rule. So we have coat weather, and for the other rule we're using regent.not coat weather. That's probably fine. I don't know, you might also want to define, in a real application you probably have more rules than this, but so regent.not works here, so this is mutually exclusive, one will return or the other will. We're using regent.find in that block below. Regent.find is going to take the logic and the data and return the entire object that the rule evaluates true, if there is one. It'll return the first one. It's modeled exactly off of array.find, so if you're familiar with the array iterator methods, find, the next one is filter, we'll be there in a second. So it'll run through the table, as soon as one returns true, it'll return that object. So we're just pulling the dot value off of it and we get that text. So now we can implement this like this. So we have our data, and then now we're just saying like const text equals regent.find, passing in code logic and data, and we're getting a value off of it. So now we've lost all of that switch statement in general. So I don't know if any of you use Redux for anything. We use React and Redux a whole lot. This is beautiful in reducers. So if you think of reducers as these pure functions, you can now just import these logic tables and pass them into regent, and regent will just set properties. So you can pass your entire Redux state into a regent query and get back something that you need out of it, and just have the reducer return that straight to the store. So you can pull this logic out. We have a couple reducers that just are regent queries. So each property that's going to come back in the reducer is the result of a regent query based on, in our actual application, like usually state of execution, wherever this insurance is being filed, changes things pretty dramatically. This is where the CLI tool is cool too. So I don't have a demo. We have it working and we use it on our project. It only works on that project. We just wrote it exactly for one implementation, and we're currently abstracting it out. But basically what the CLI tool does is we've taught it where all our logic files and our rule files are, and it runs through and converts all of that stuff into Markdown. And then we check in that Markdown file. So what happens if someone goes in and changes like the code weather temperature to 80, in the diff, you now have the ability to send the meteorologist a difference and say like, hey, code weather is changing to 80. You can go look at this file. It is documentation that you never have to touch, and it's driven completely off of the rules and logic tables that you've set up. Man, I wish I had a demo. It was close. It was close. Although, I don't know, I barely got these slides together in time, so maybe we weren't that close. All right, so a little bit of fanciness. So regent, we keep using this. This is a little bit ugly, I think, this regent.find everywhere. And you pass in code logic and data. We took a nod from Lodash and to support currying, we decided to go this way. So basically, because you're always passing your logic or rule in first, you can curry, find, or filter, or evaluate, or explain, and then what returns is a function that just accepts data. So you can turn any of these, you can hit an API, get a JSON rule back, you can pass that rule into, you can curry that rule, basically, and pass it in, and then what you get out is a function that will return true or false based on the data that you give it. This is really nice. Using this find is great. We do this all the time. So in this exact example, having text equals find code text data, that last line is nice. We do all of this curry business in the rules file and just export the executable functions alongside of the rules. So if you just need a function like, same thing, like is New York or something, you just have an is New York, and that's just built off the same New York rule that everything else in the entire application uses. It gets a little bit nicer if you're going to do that a whole lot. Oh, this is evaluate. Sorry, so this is what I was just saying, like the is New York rule. And this is one. This is sort of the pattern that we use. So, well, the second line here, we just define a function make, and that just takes a rule and does that curry behind the scenes. So now to use this, you can just call make and pass it a rule, and you get an executable function out of it. None of this is built in, right? Like I tried to show that we're just importing Lodash curry in this example. We didn't want to bake make in. It's just a one-liner, and we didn't want to sort of prescribe one curry over the other. I know Ramda is really popular with people that are younger than me. So yeah, this more or less ends my high dive on Regent. This is a really good time. I have a little bit more to say, but this is a pretty good time to pause for questions. I know I talk kind of fast, and I don't know. Does anyone have any comments or questions or concerns? Angry pitchfork mob sentiment? Yes.
So one thing that kind of came to mind was when you're nesting, kind of structuring all these rules together, does it kind of depend on the data having that specific shape?
Each rule is responsible for knowing how the data is shaped. So yes, to answer your question, it works because of that. It works really, really, really well with Redux stores, which sort of have a predictable shape by nature of. It'll yell at you if you if you have a property that it doesn't have a reducer for. But yeah, for sure. We have an entire data service that sort of sanitizes these contracts and sort of brings them into the Redux store shape that we need, and then each of these accepts that. But right, if you had, I guess, multiple places where you had like a mid-temperature and there were multiple paths to it, I guess you could do two rules, but in reality at that point I'd probably be writing something to make sure there was just one of them. But yeah, that's a good point. Each rule, once you define a rule with its Lodash get path, like if that path isn't there, it'll just return false. It won't die or anything. But
cool.
Yeah. Anyone else? Yeah.
I think you might have actually shown this already, because I'm thinking in my head how I would use this to solve that problem. But like for the regent.or, regent.and strings, like if you need to do a more complex logical, where you might have multiple ands, ors, etc. put together, like how do you work with that? Can you only do the kind of solid and or would you kind of nest those rules into your regent rules specifically?
Yeah, that's a really good question. The second one. So we build up that logic. I'm trying to think of a good example. We haven't gotten a logical tree that we couldn't solve, but you do definitely want to keep everything as atomic as you can. It really is the best way to talk about it. We call composed rules molecules. So you define each piece as tiny as it possibly can. So the only time we don't do that is you can write custom evaluators, right? So you can write any function. So if you were gonna do something like, is tomorrow's temperature greater than today's temperature? That's probably the case for an evaluator. You could, as in that example, you could just use the Lodash.get array syntax to do 0 and 1, but if you didn't know that it was 0 and 1, if you didn't know the array indexes, you could just write a function that took all of your array of data and figured that out and returned true or false. And then that's where you start to get sort of big. Any small piece, so if you have is it going to rain? I'm trying to think of whether is it windy? You know, like snow, I suppose. I guess the temperature would handle snow, but like if it's snowing, you probably want to code. All of these things you can just continuously compose. You can compose any number of levels deep. So, you know, if you just have a single rule, you can compose that with an or, an and, or a not, and then you can take the results of that composition and compose it with another piece, and you can compose multiple pieces there. Some of these, the example I had in my internal talk with the real logic, I have just a regent.explain that's just stupid. It doesn't even help. It's so complicated. Like it's horrible. It's just horrible. But it's way better to be able to read that and like sort of say, like, I'm not going to do it in the next 10 minutes. I'm just going to read this 4 times and figure out what it's saying, than it is to have to like go dig through the code and figure out why. That is a good question. Yeah, I guess keeping things as small as possible and composing them in their next smallest pieces, and then composing those in their next smallest pieces and going up. Anyone else? I have a beautiful little case study that I think I've scrubbed personal information from. This is the first time I've used the slide deck, so we're going to go. The curious case study of the tester, which used to be a real human being's name. I gave this talk right before the Oscars the first time, so that was a Benjamin Button pun that doesn't work, not at Oscar time. Anyways, so I once worked with a QA resource, and I'm not going to use their name, so I'm going to call them the tester. This example is just in the spirit of the bug that the tester found. This has really nothing to do with what it actually was. Obfuscated away the nature of the application. We're sticking with the film metaphor. Act 1, the tester finds a bug. So the bug in question was related to an image in our application, presumably. So what's the problem? We were rolling out a new feature, and it related to the production of a new widget. If the customer pays an extra fee, the name of the widget should be new widget, and the image should be of this new titanium fancy widget, and not of the old classic widget. So the tester noticed that even after paying the fee, the UI does not display the new image, which is showing the old image of the widget. What to do? I feel like classically, what to do would be bother me. He would say like, bug, Jira, here it is, like backlog, priority highest in the world, like stop everything, do this, and like here's your acceptance criteria, and here's like a 10,000 line contract to reproduce it. And it would just burn a bunch of time for him to do that, and then it would burn a bunch of time for me to read it, not understand it, and just walk over to his desk and say like, I don't understand, what do you mean? And then he would show me. What actually happened is way cooler, and I think it's Regent's fault. Hopefully you will too. So the tester heads over to widgetimagelogic.js to see what's going on. So we just have a tables folder in our project, and inside it are all of these logic files. And there's a widget image logic. It was just named something. And he looked at this file, and this is sort of what that file looked like, pretty dumbed down. We're importing everything. We're just exporting one huge object as R for all our rules because we use so many of them. And then there's an image source, and it's a path to an image. And then there's a rule for standard payment, and then that's it. So like there's nothing in here relating to new widget at all. Like, how would we ever get the new widget image? Of course this doesn't work. And he can read this because you can just sort of see that there's an image source property and a rule, and you don't need to see like, oh, is this a problem with the if statement? Is this a problem with logic somewhere else? Like, where is this bug? The bug is here. The bug is in the logic. So the tester headed over to rules.js to see if he can find a rule related to not eagerly saying that didn't get scrubbed. New widgets. So in our rules file, good thing that's an acronym that I don't even know what it means. I think that's probably fine. In our rules file, among other rules, he saw that there was already a new widget payment rule defined. So this already existed. We were using this in the application in a bunch of different places. It just wasn't being used for the image. And you can look at it and see that it just means this new widget payment field needs to be true. And he looked, and it was true, so he knew it was a bug. Now he had everything that he needs to write his test cases, and he was able to create like a Selenium test that exercised this bug by making sure that that thing was set to true and then showing that it wasn't there, which is great. Like, that's a huge step in the right direction. But we even went farther, because now that he saw that there was this new widget payment, he just jumped back to this file and added the second line. Image source equals new image.jpg, and rule is new widget payment. I just think this is beautiful. So this really happened. I didn't even know that he was touching the repository until he said, hey, I need to unit test this or I can't check it in. I've heard this guy in the past say, I'm not a developer, I'll never be a developer, testers shouldn't be developers because like, you're too close to the work. He went on this huge rant about how he's objectively not a developer. Like he would say that too. And here he is fixing bugs in our application. And I would say that these aren't bugs. Like this is a bug because the application is broken, but it's not a bug, it's not a coding bug, this is a configuration bug, right? Like the application is doing exactly what it should be doing. We just aren't telling it that there's a new widget. Because we don't have like if this store property is true, like spread all throughout our code, like this isn't a problem there. It's just that our logic file wasn't configured, it just wasn't added. And this, I don't know, I hope I'm not like beating a dead horse, but it's just really beautiful when stuff like this happens. Like when you can say, you don't have to write a unit test that this image shows up. Like sure, you should write like an end-to-end API test that makes sure that widget or that image shows up and a bunch of other things happen. But like because Regent's 100% unit test coverage, you don't need to test these configuration files. Like the way that we test these configuration files is by checking in the markdown file that gets spit out, and then every time that changes, anytime there's a diff on that file, we say like, okay, like something with a rule or a logic file has changed. Let's make sure this still reads right. But there isn't anything else that can go wrong here. It's either configured right or it isn't. Yeah, this slides. In a nutshell, it's the beauty of writing self-documenting code. You don't need to be a developer to understand what the application does or should do. So like you can look through this if you know that the rules file exists and you know that the logic files exist, or when our CLI tool is done, you just know that there's this markdown file out there. You can just read the bugs, and it's pretty awesome. This case saved us countless hours. This has happened more times than once. This one actually happened like the day before I gave this talk the first time, so I was super excited to add it in. Writing code this way has also helped me personally, sort of like I was saying, I don't know if anyone's worked on an internationalized application, but it's just sort of made me change the way I think about writing code. And I found a video series that I've been in love with from MPJ, if anyone's seen it, functional programming. I've been on a huge functional programming upswing. And Regent works really well with that. Like, Regent's pure, you give it everything it needs, and it'll just give out a single property. And they go really well hand in hand together. That does bring me to the conclusion. Does anyone have any other questions or comments? Or there's probably an angry mob slide. Thank you for listening. Questions, comments, angry rants? Cool. I'll happily type npm install Regent on everyone's computer. Together. Stars on GitHub. If you're giving away stars. Sweet. I'm going to publish these slides at regent.explain.ninja. Actually, they're probably already there. I don't have the Wi-Fi configured on my computer.